exercise 2.2c, we are asked to find the HCF of the following using index notation. So we have about 10 questions where we are asked to solve using index notation. In solving this exercise, all we are going to do is to express each of these pair numbers as a product of its prime factors. Thereafter, we look out for the common factors, and the product of the common factors gives us the HCF of the paired numbers. Question 1 on exercise 2.2c, we are asked to find the HCF of the following using index notation. Now, HCF simply means the highest common factor of these two numbers. So, using index notation, all we are going to do is to first and foremost express 288 and 432 as a product of its prime factors. Thereafter, we shall look out for the common factors, and the product of the common factors gives us the HCF, or the highest common factors, of 288 and 432. So let me express 288 and 432 as a product of its common factors. So 288, beginning with 2, 288 is said to be divisible by 2 because the last digit, which is 8, is said to be a multiple of 2. So therefore means that 2 can actually divide 288. 2 into 2 is 1, 2 into 8 is 4, into 8 is 4. 144 is also said to be divisible by 2 for same reasons. 2 into 1, it cannot. 2 into 14 is 7. 2 into 4 is 2. 2 can still divide for same reasons. 2 into 7 is 3 times remainder 1. This becomes 12. 2 into 12 is 6. So long as 2 can still divide, keep dividing by 2. 2 into 36. 2 into 3 is 1 remainder 1. 2 into 16 is 8. 2 can still divide. 2 into 18 is 9. But 2 can no longer divide 9, so we therefore use 3. 3 into 9 is 3, and 3 into itself is 1. So that 288 can be expressed as a product of its prime factors to be 2 times 2 times 2 times 2 times 2 times 3 times 3. We also do same to 432. Divide by 2. 2 can divide because 2, which is the last digit of 432, is said to be divisible by 2. So 2 into 4 is 2. 2 into 3 is 1, remainder 1. 2 into 12 is said to be 6. 2 can still divide for same reasons. 2 into 2 is 1. 2 into 1, it cannot. You put down 0, and this becomes 16. 2 into 16 is 8. 2 can still divide for the same reasons. 2 into 1, it cannot. 2 into 10 is 5. 2 into 8 is 4. 2 can still divide. 2 into 5 is 2, remainder 1. 2 into 14 is 7. So 2 can no longer divide 27 because 7 is not a multiple of 2. So let's test for 3. Can 3 divide? 2 plus 7 is 9. And 9 is a multiple of 3, which is the condition for any number to be divisible by 3. That is, the sum of the digits in that number must be divisible by 3. So 3 can divide. 3 into 27 is 9. 3 into 9 is 3. 3 into itself is 1. So expressing 432 as a product of its prime factors, we have it to be 432 to be equal to 2 times 2 times 2 times 2 times 3 times 3 times 3. We have 4 sets of 2's here and 3 sets of 3's. So we shall then look for the common factors. I shall group them. 2 is common. another 2 is common, another 2 is common, another 2 is common, these are not common, so 3 are said to be common. So therefore, the HCF is said to be the product of all the common factors, which is 2 times 2 times 2. I'm picking every pair. This is 2 appearing 4 times, which is this, times 3 appearing 2 times. 3 times 3. They say we should find the HCF of the following using index notation. So the HCF is going to be 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. 16 times, this is 16 times 9. So we have 16 times 9. 9 times 6 is 54. You write down 4 and carry 5. 9 times 1 is 9 plus 5 is 14. So the HCF is said to be 144. What that means is that 144 is that number, is the highest factor that can divide 288 and 432 without a remainder. Kindly like my videos as you watch. But I recommend that you subscribe to my channel on YouTube and also on Facebook. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. While I recommend you share the link with your friends and families so that they can also benefit from our daily classes. We shall now take the next question on exercise 2.2c.